which is more on polynomials. The next couple lessons are a lot of algebra, and we want to make sure we practice this algebra. So I want you to take good notes on how we divide polynomials. Okay, so which is our goal here today? By the end of this video and by the end of class tomorrow, we want to be able to say divide any polynomial of degree, say 3 or 4. And by a particular binomial, say like x plus 4. Okay, so that's a binomial, and a polynomial is maybe like x cubed plus 3x squared plus 2x plus 1. So we want to be able to divide that up by that. And that's goal number 1. Goal number 2 is use something that we're going to define today called the remainder theorem to solve some problems. Okay, so let's go over division. If we're going to divide, let's go over how we divided back in grade 4. I'm going to divide 125 up by 4. Now, you're used to just throwing that in your calculator, but if you didn't have a calculator, we want to say, well, how many 4s go in 125? Or 125 is equal to, like another statement it would be, say, is 125 is equal to something times something. And one of those somethings is 4. Okay, so 125 is 4 times some other number. And we want to know the one other number. So to solve that for that one other number, we would divide 125 by 4. So that's kind of where we're going, what we're getting at when we divide polynomials. Okay, so as a side note, we're looking at, say I had that x cubed plus 3x plus, 3x squared plus an x plus 1. If we want to know, say, what that is equal to, you know, these two things multiplied together. So if I knew one of them was x plus 1, then I could find what the other thing is by dividing. Okay, so which is kind of like a lead-in. Notice, here's a standard form, here's factored form. So it's kind of lead-in to how we could factor polynomials bigger than quadratics. Okay, so in order to do that, we got to go over these basic skills, because that's what's going to come into play here. So remember what you did? Remember how to do it? How we do this using long division? Remember, we would put a 4 here, and we put this little symbol up like that. It looks like a square root, and we put the big number in here. And we'd say, well, we're going to divide 125 up by 4, and we do long division. Okay, so you're not thinking about, well, how many times does 4 go into 125? We break it up. We first say, well, how many times does 4 just go into, now it doesn't go into 1, so it goes, let's say 4, how many times does 4 go into that 12? That's easier to work on. So 4 goes into 12 exactly 3 times. So I'll put a 3 up above the 2. Is this coming back? Is this ringing any bells? So I put a 3 up there to represent that 4 goes into 12 3 times. Okay. Once you've done that, you put the 3 up there, and then we do 3 times 4. So long division would say, well, 3 goes into 4 12 times. And so we'd write 12 underneath. And then what we do is we subtract the 12 and the 12, and we get a 0. Because it went in perfectly. That's why. We got like a little remainder of 0 going on there, right? 4 goes into 12 3 times exactly. Now, we still have to worry about this 5 over here. So what we do is we bring it down. And now we worry about, okay, so well, how many times does 4 go into 5? It doesn't go in, it goes in at least once, right? 4 goes in there once, and then not another time. Okay, so we say 4 goes into 5 one time, but then no more than one time. Okay, so there's some extra there going on. Okay, so we continue this process. Okay, so they go in there once, so now it's 1 times 4 is 4, and we write that underneath. And then we subtract. And we get 1, and that's the idea. That's our remainder there, right? So we went in like this. That 4 went into that 5 one time with 1 left over. Okay, which means, now look at the number up here. 4 goes into 125 31 times with 1 left over. So when we say 125 divided by 4, that's equal to 31 with 1 remainder. And we can sometimes use an R for remainder, like with remainder 1. That's what we would have done in grade 4 or 5. So you can check that on your calculator, that if you take 4, so notice if I write it kind of like this 125 is equal to 4 times 31, but with 1 left over. Okay, so if you notice, get your calculator out, go 4 times 31, add 1 more, you get the 125. Okay, so that's kind of how we can write, or how we can do long division. I wanted to make sure we remember those skills, okay, because what we do to divide polynomials is the same process. So let's go right into it. Let's say I have this cubic polynomial here, ends there, and I want to divide it by x plus 9. So we're saying, well, how many times does x plus 9 go into that? Or alternatively, it means this statement, x cubed plus 13x squared plus 39x plus 46. That equals some factors, x plus 9 times something. Maybe a remainder, maybe not, maybe it goes in there perfectly, we don't know. But x plus 9 times something is this big expression here. Okay, so what we want to do is figure out that something. In order to do that, we divide. So notice we're going to be dividing this big thing by x plus 9. And since we're dividing by x plus 9, we have to talk about restrictions on our variables. Since x plus 9 would be like a denominator in a statement like this, okay, so we're kind of doing this and we're simplifying, and so we're dividing these two things. We have to talk about what our restrictions on our variables are going to be. Now, since we're dividing by x plus 9, we think, well, what can I put in there to make 0 in the denominator? Because we can never divide by 0, and that's the way we want to look at a restriction. Clearly, x cannot equal negative 9. If it was, we divide by 0. So this is our restriction on our variable. X cannot be negative 9, so we'll keep that to the side. Okay, so let me actually divide these now. So I want to divide that big thing by that. So we set up the same way. We write the symbol like we would have done with the numbers. We write the big thing underneath, the whole polynomial, and then we put what we're dividing by out front, just like we did with the long division. Now, if you weren't sure, go back and watch the pause it, go back and watch the other part again where I did long division with just numbers. Okay, so now, like what we did before, we think about, well, how many times, we don't want to think of how many times does this go into the big thing. Let's just do it part by part. So here's how it works with a slight difference. Instead of saying x plus 9 goes into all this, I just look at the x and look at the first term here. If I take x and multiply it by something, I need to get x cubed. Okay, so it's like, how many times does x go into x cubed? Well, like, what do I need to multiply x by to get x cubed? That one thing is an x squared. Okay, so x times x squared is the x cubed. Okay, so here's what we do next. Just like what we did with long division, we would then multiply back and then write it underneath. So I'm going to go take x squared, and I'm just going to do part by part. I'm going to go x squared times x, which is x cubed. And then I'm going to do the x squared plus 9, or times plus 9. Okay, so I got x squared times 9 is plus 9x squared, and I write it underneath, just like the long division. Just like the long division with numbers, we're now going to subtract and see what's left over. So notice x cubed subtract x cubed, that's going to be a 0, and that's going to work out nice. Now I have 13x squared and 9x squared. Look, they're like terms. I can subtract them. So 13 subtract positive 9. So I'm going to put a bracket around here so that we don't get confused. 13 subtract positive 9. What's that, 4? So we got 4x squareds. Okay, so x plus 9 went into an x cubed plus 13x squared. An x squared now in times, but with this 4x squared left over. Okay, so we repeat the whole process. And what we'll do is we'll bring this one down, just like we did the other one. We bring whatever we didn't use down. So I put a plus 39x. But I don't worry about that now. All I'm going to think about is what times x gives me 4x squared. And I know that to be 4x. 4x times x gives me 4x squared. So now we go through again. 4x times x, that's 4x squared, and those two will subtract out in a minute. And then the 4x times 9 plus 36x. subtract. Notice these are 0. These are going to be like terms. So 39 subtract positive 36, that's 3x. That's my remainder there. Going to bring down this one. Last one. That's a plus 46. So now I'm looking at, well, x plus 9 goes into this so many times, but take it part by part. X times what is 3x? Well, plus 3. So 3 times x is 3x. And 3 times 9 is 27. And subtract. Notice the 3's are going to go. Now it's 46 subtract 27. What's that going to be? What's 46 subtract 27? Oh, okay, so 27, that's going to be 20, that's 47, this is 19. Okay, so now I have a number. There's nothing else to bring down. So this is my remainder. So x plus 9 goes into this big expression this amount of times with 19 left over. Okay, so how we can write this and what this means, and we write, we've divided, okay, and this is our quotient. We call that a quotient. Quotient means, the answer after you've divided. That's our remainder. Now what we can do is write a quotient statement that would say what you just did. Okay, so I usually like to write my statement like this, that x cubed plus 13x squared plus 39x plus 46. I'm going to run out of space, so I'm just going to keep continuing. You're going to write equals and then keep writing. That equals 1 factor of x plus 9 times what we got, x squared plus 4x plus 3, but we had a remainder of 19, so plus 19. Okay, so x plus 9 didn't go into this exactly perfectly. It had a remainder of 19 after, with this value resulting in its quotient. Okay. Now, I'm going to do another example, and then I'm going to show you one more, say from YouTube. I want you to take good notes on all of them and see how all of them are done in the same format.